Appreciate that, Jason. So one of the things that I really don't like to talk much about is myself. So what I'm going to do, if I can get my stuff to cooperate here, what I'm going to do is just show you guys this. Jason, can you see my screen? Just want to check.
Yes, we're good.
Okay, fantastic. So I've been doing training in the construction codes and in residential construction for 21 years now. And I'm a fourth generation home builder, or was. My last job, I was the paid construction director for a Habitat for Humanity affiliate. So when I hear people say, well, affordable housing can't do these things, I call bullshit on it, because I was doing it 20 years ago. So it's okay. It can happen. We also spend a lot of our time in our companies and our brands doing quality assurance work. And the most important thing is that you need to know about me is in this photograph. Those are my parents. And that's my dad. And my dad had one big rule for us. And that was build everything as if you were building it for your mother. And my mom had one big rule, which was do everything as if unto the Lord. So what we had to do didn't have to be perfect. It just had to be good enough for God. So that's kind of the attitude that we had. And if we made a mistake, after he beat the crap out of us with a 2x4, he'd tell us, if you don't have time to do it right, when are you going to have time to do it over? And we see a lot of things just baked into particularly in ventilation, just baked into the building that's going to cause failures. I'm going to talk about some of the bigger issues. But I always start off with, like, what are the questions that I had? Like one big thing we get a lot is, why do we ventilate houses? And then some people ask, when do we need to ventilate them? How do we do it? Where is this appropriate? Usually one of the last things they ask is, what does the code say about this? And the last thing that a lot of people ask me, because it's not really on their mind, is what really happens. Because a lot of times they think that because it's in the code, that's the way it happens, because that's the code. And we often find that a lot of people don't read those sections in the code book when they go about building a house. And then there's some challenges that are baked into ventilation systems, particularly the intermittent one, the source control ones, like your bath exhaust fans, kitchen range hoods. They all have to be exhausted to the outside, but we often find that they're not sealed. So they leak a lot. So you get a lot of moisture, because those are just for moisture removal from the bathroom and the kitchen. We get a lot of moisture introduced into the attic spaces from those things because they're not sealed. We also have some challenges in colder climates where, you're taking a hot shower in the wintertime and the duct isn't insulated. And so that warm, moist air coming out of that bathroom ends up condensing inside that duct, and it looks like a pregnant snake up there. I had the unfortunate experience in Alabama of doing some QA on a house, and I was standing right underneath the bath exhaust fan when the person in the attic said, "Hey, this duct looks pregnant." And then I said, "Don't touch." And about that time, they lifted it up, and I got about 2.5 gallons of water dumped on my head. Not really water, but all this other stuff that comes out of your bathroom. There's a lot of stuff that really happens in the field. There's one of the big challenges with the source controlled ventilation points in the bathroom is the electricians install the box, and then the HVAC guy runs the duct, and the electrician doesn't care if his outlet for that fan box is 2 inches away from a ceiling joist. They don't care, because that's not their job. And then the HVAC guy comes in and he bends that duct around in a 90-degree angle or worse. Some of them go 180 degrees, and he doesn't move the fan box because that's not his job, and it's just this lack of coordination and all of that. It just causes lots of problems, because you can't move the same amount of air through a 90-degree bend or 180-degree bend as you can through a straight duct run. So these are kind of like the questions that I want to answer today. And if you have these questions, that's great. If not, ask away and we'll figure it out. We'll have a great conversation.
I got to push back already though, Brett. Because I've seen enough of those ventilation fans installed by electricians that, to me, it's quite obvious the electrician does care how he installed it. And it's also quite obvious that evidently the HVAC guy is dating the electrician's ex-girlfriend, because that's the only reason he could have installed it the exact wrong way that he should have. I mean, you see it all the time, right? It's like, well, it could have been a little 3-foot straight run to the soffit, but instead you've turned it 180 degrees right against the joist, and you've made it almost impossible to run the duct now.
Oh yeah, I mean, we see that. I mean, it's almost guaranteed, and that's usually the number one cause of failure. Because when we come in at the end, when we test these things, when we get low flows out of them, we generally, I mean, like, okay, well, why wasn't this fixed at rough? And that was because nobody was looking at it at rough. And it's not actually on any energy rater's list of things to look at. So,
but as inspectors, as city inspectors, so for the city inspectors on the webinar, when you see one of those exhaust fans and the outlet isn't positioned such that the duct run can be straight as possible. Now, granted, the IRC is not going to say that, but I can guarantee you in the manufacturer's installation instructions for that exhaust fan, it will tell you to position it such that you can run as short and as straight as of a duct run as possible. So when you see those things installed exactly backwards, make them reinstall it. Make the electrician, I mean, just ding that on the electrical rough end. You don't have to shut the job down. That can be one thing, correct and proceed. You can check it when you're back 3 or 4 days later to do the insulation inspection. But even though you can't find, that's not going to violate 1603 or whatever code of the IRC, but it is, first off, it's best practice, it's common sense, it's workmanlike manner. But second off, that can be manufacturer's installation instructions as well. So I think as a city inspector, you have all the power you need to correct that.
And when ventilation testing becomes, adopted into the codes, there's going to be a lot of failures at the very end when these things are really hard to fix, if this doesn't happen. So one of the things that always gets me too is that, most of the ventilation that we have in homes, the big ones, the kitchen, range hood, and the bath exhaust fans are for moisture control. A lot of people put the bath exhaust fan in the bathroom, in the toilet room, if there is a separate toilet room, and they think it's for odor control. And the reality is it's not. It's there to control moisture. And, it's not there for the odor. And the reason why we have whole house mechanical ventilation, which has been in the code since 2012, is to dilute any pollutants that we have. And then I have my curmudgeonly aspect shows up. I think a lot of this is Yankee revenge. As you'll see when we start introducing an excessive amount of ventilation in the South, where we have, hot, humid climates, bad things start to happen. And I think it's, Joe Stebrick and I have had some serious knockdown arguments. But one thing that I do agree with him on is that people in the South shouldn't listen to people from up north on how to build. And I totally agree with that. And that's what I tell Joe every time I hear him coming down in the South, because he's a Canadian that's from Boston. But one thing that he did get right is people down here shouldn't listen to people up north on how to build. So one of the big questions we have is, when do we need to ventilate a home? And, the answer is, really, I mean, from a science perspective, it's conditional. What's the occupancy rate of the home? Do they have a lot of pets? What are their behaviors? Do they smoke in their house? What's the climate like? What could we possibly be introducing from the outside in? And I had a guy argue with me one time. He said that, you couldn't introduce pollutants from the outside into a house through ventilation. And I was like, are you nuts? I don't know if anybody lives in the San Antonio, Austin area, but, we get this, the cedar blooms or the pollen that it's just ferocious. And then there's always the chemical things that happen when you've got, some kind of manufacturing plant, like a paper mill or something else going on right next door to you. Those are serious pollutants that can be introduced into the house through mechanical ventilation. And then the other one that we have is, what kind of pollutants are actually inside the home? A lot of the research that was done on ventilation that sort of was driving the ventilation requirements was based on the 1990s studies that came out of Southern Ontario, Canada, where there was a lot of pollutants from the glues that were in the OSB and all kinds of other things, and the VOCs, the volatile organic compounds that were in carpets and paints. But a lot of that, the manufacturers have cleaned up over the years. So one question that I always have is, is anybody looking at what pollutants are in the building materials that we install in homes today? And where's that research? And I don't think anybody's really looking at that anymore. So just from a science perspective, these are the kinds of things that we look at. And then how should we ventilate them? And, we've got the intermittent source control. So for bathrooms, it's supposed to exhaust 50 cubic feet per minute. If it's intermittent, and 25 CFM if it's continuous, and kitchen range hoods, 100 CFM. If you're doing the whole house mechanical ventilation, which again is in the code, we've got some choices. There's supply only, where we're actually bringing air from the house, from the outside into the house, usually getting introduced to the mechanical system from the return side of the air handler. We've got exhaust only systems where we're exhausting air from the house to the outside. The code is silent on which one you should use. Energy Star is silent on which one you should use. And then there's these so-called balance systems, which are like an ERV or an HRV, but they're not really balanced. There's always a slight imbalance because they're trying to create a positive pressure inside the house to help reduce pollutants that can enter in through infiltration. So they're not really perfectly balanced. They're slightly imbalanced. And then we have controls, and we've got everything from no controls. We just had a call yesterday. Builder up in Iowa was doing, he was doing a no control supply only ventilation system into the house, basically by just bringing air directly from the outside. There's absolutely no, it's just an open duct. And it's like, that's doesn't meet the code at all, not even in Iowa. And it's just bad building science. And it's just a really bad practice. And then we've got timer controls, humidity controls, temperature controls, and then we have humidity and temperature controls. And the code is silent on all of these with the exception of the timer controls. And and that's what gives us intermittent operation of whole house mechanical ventilation. Energy Star has come out and said that anything that controls humidity and temperature that will reduce the amount of overall ventilation in a 24-hour period of time is not an acceptable control system for their program, because they want to make sure that over a 24-hour period of time, the house is getting the required amount of ventilation. But, the code basically, you can put in a timer or you can have it run continuously, but those are your options. And then we have the big challenge of where do we do this? And everybody's probably familiar with the climate zone map. And, we've divided it into hot, humid, sort of the humid south is underneath that white line that you see on that graphic. The hot sections are usually climate zones 2 and 3. They're hot. And then of course we've got the dry side west of the black vertical line, and then wet side east of that. Although we do have some places of moisture on the west coast once you get up into the marine climate up north, climate zone 4, up in Oregon and Portland along that coast. So where do we have this? Where are these controls appropriate? On a supply only, you can have timer controls, you can have humidity controls, temperature controls. Exhaust only, you can actually rig it up with a timer control. And then the balance systems can have the same, timer, humidity, and temperature controls. But where are these things appropriate? Where is these types of controls appropriate? And the answer is really, it depends. If you're in Arizona, you probably don't need humidity control, but you want temperature control. You're probably going to want a timer control. no matter where you are. If you're in the hot, humid South, you're probably going to be looking at temperature and humidity controls, possibly, unless you're doing Energy Star, in which case you're not going to be looking at those. And then, the big question is, what is the HVAC guy doing? And this is where we find a real lack of knowledge into how to think about ventilation, because this is kind of what the code says. First of all, we've got standards, which are separate from code. And ASHRAE's 62.2 is the ventilation standard for residential buildings. A friend of mine, Ian Walker, he's just finished his chairmanship of that committee. He's happy to be off of it as chair. But they've released their latest version, was in 2019. And Building Science Corporation, which is Joe Stiebrick's company, they produced their own standard back in 2013. And it was based on an earlier version of the ASHRAE 62.2 standard. But the code has referenced mechanical ventilation as a mandatory requirement in the code since 2012. And any code references that you see in the rest of this presentation are based on the 2018 IRC. And I believe in the 2021 IRC, that's where the mandatory testing requirements come in for ventilation.
And yes, sir, they do.
So this is kind of crazy when we start looking at how it gets calculated, because the different standards have different calculation methods. So, for example, the HERS index, which is a proprietary rating system, is based on ASHRAE 62.2 2013. And the ventilation rate is the conditioned floor area times 0.03. So that's 3% of the conditioned floor area. And then the number of bedrooms plus 1, because we always assume there's 2 people in the master bedroom, times 7.5. So there's 7.5 cubic feet per minute per person that's assumed to be in the home. Now, one funny thing is, when I was in college, I was a pre-med student. And one thing I learned was that there's only the human lung capacity is only about 1 cubic foot. So they're providing 7.5 cubic feet per minute per person, plus 3% of the conditioned floor area. And then you look at the energy rating index in R406, it follows the Building Science Corporation standard because they got that into the code language. And again, this ventilation rate is the conditioned floor area, and it's only 1% of the conditioned floor area, but it kept the 7.5 CFM per person, once again, assuming that there's always 2 people in the master bedroom. I don't know why they assume that. More often than not, we find it's only 1. And then there's the prescriptive, the UA, and the cost performance paths. So in section M1505.4.3, it follows the Building Science Corporation standard, which is 1% of the conditioned floor area, 7.5 CFM per person. Or you can have this table, which is based on the square footage of the house and the number of bedrooms. And you just follow the table. This is pretty prescriptive, pretty easy to do. One of the big challenges that we have is that we get a lot of HVAC contractors who say that residential mechanical ventilation is not required. And they give a lot of folks that are testing these things and inspecting these things for various programs a lot of pushback, saying it's not required in the code. And the reality is it is. It's a mandatory requirement in the energy section, and it references the flow rates that are required out of the mechanical section. So it is a mandatory requirement. So here's an example of what you get when you do the math. Looking at the same 2,500 square foot 3-bedroom house. HERS index, you need 105 cubic feet per minute. Energy rating index, you need 55 cubic feet per minute. Same thing when you look at the mechanical section. If you look at the table, though, the table requires 60 CFM because the table is based on that range of 1,500 to 3,000. So it's based on a 3,000 square foot house, the upper limit of that, of each section. But then what about the intermittent side? So that's continuous insulation. That's 55 cubic feet per minute or 60 cubic feet per minute, depending on which path that they've chosen. Or if they're doing a HERS index, 105 cubic feet per minute. Continuous insulation. Most of them aren't set that way.
Well, continuous ventilation, not insulation. Yeah, that hers is that's crazy to me. Anyway, keep going.
Yeah, I I agreed. And I chaired the committee when we produced that, but my job as chair was to get the poop through the chute, not necessarily to intervene on things. We argued the best we could through proxies, but we lost the argument. So when we get into the intermittent side, there's two things that get looked at. First is what's the required airflow, and then there's this thing in the code called an intermittent factor, and it comes from this table. And they say you can interpolate within the table, but you cannot extrapolate beyond the table. That's actually footnotes in the code. And it gives us a factor so that if the runtime in a 4-hour segment, so again, it has to run at least once every 4 hours. The runtime, if it's 25%, the factor is 4, 33, it's 3, and so on throughout the table. So what does that look like? Well, let's look at our 55 CFM house. Continuously 55 CFM. If you set it for 15 minutes an hour, you've got to introduce 220 CFM while so that's cubic feet per minute for each of those 15 minutes. If the timer control is set for that. 20 minutes, it's 165, 30 minutes, it's 110, 40 minutes, the math works out to 82 and a half. So, you know, I'd be happy if we got 82 or 83 or higher, or, you know, as you'll see, I'm not really a big fan of excessive ventilation. 45 minutes, you know, 71, 71 and a half, 72. And if you run it for the continuous, again, it's 55. But what really happens? So what we typically see, West Texas, we typically see an exhaust fan in the utility room, and that sucker moves somewhere between 25 and 40 CFM. I looked at a bunch of the data that we have on houses from Laredo to El Paso, and the average exhaust fan in the utility rooms is moving between 25 and 40 CFM. So it's right around 30, 35 CFM is what their average is. And, you know, when you're supposed to bring in 55, that's clearly a failure. And when that becomes a mandatory testing requirement, these houses will be failing at the end when it's really difficult to fix it. It's really difficult to get in there and turn that fan box around without tearing a lot of stuff up. And it's usually the reason we're getting these low flow rates is because the exhaust port on the fan is pointed in the wrong direction, and it's usually up close to the framing. So we end up with a serious restriction and constriction on the duct side.
You know,
so the other thing
that the manufacturer of the fans, when you read the installation instructions, those CFMs advertised are based on a 4-inch rigid metal duct as well.
Yeah, not the flex duct that we usually see, which was never intended for this purpose, but it gets used that way. Yeah, it sucks. And then on the other thing that we usually see everywhere else is they're bringing air in from the outside to the return side of the air handler, and they've got a timer control and a motorized damper. It's commonly known as an air cycler, which is like Kleenex for facial tissue. It's not just air cycler that makes in just about every manufacturer of these of HVAC supply ducts and whatever and control systems make these things. And so what we usually see is a 6-inch duct that runs to this motorized damper with a timer control. And they typically are moving about 60 CFM when we test them. Regardless of the size of the house, typically we're seeing about 60 CFM. But the real challenge, they set the timer control to 5 minutes. So let's talk about what happens.
Yep.
That means to bring in the code required amount of ventilation, they have to be bringing in 660 cubic feet per minute. And you can't get that through a 6-inch duct. The next most common setting that we see is 10 minutes, which means they have to pull 330 cubic feet per minute. And you might get that through a 6-inch duct if you put in a heavy-duty booster fan, but neither of these are code compliant. The second problem is, let's say it's required at 55. We measure 60. The required timer setting is 55 minutes an hour. So when this is hooked up to the air handler fan to provide the fan motor for ventilation, and you're looking at a Carrier furnace or something, like that, you can get up to almost 1,300 watts. And looking at San Antonio, the additional runtime in San Antonio is going to be an additional 13 hours on top of whatever the daily average runtime is for the HVAC system, which in San Antonio is about 9 hours. So all of a sudden, there's 13 hours that more than normal than that HVAC system is going to be operating, pulling almost 1,300 watts.
Yeah, it's such a travesty. That's when we went from the 06 to the 12 energy code in Granbury. I was building official, and I mechanical ventilation's required now, guys, and they all switched to that controller with into the return plenum on the HVAC, and it still gives me nightmares that I didn't know enough then to direct them away from that, and make them do something else. But like you said, they were all set. So there's 3 dials on that controller: square footage, number of bedrooms, and runtime. Or anyway, like you said, they were all set for 5 minutes. And frankly, in my opinion, 5 minutes, if you don't have pets, and it's especially on some of the, we were averaging 3,000 square foot homes at, right at 3 air changes an hour, and you don't have pet. Anyway, my main thing to the builders was have a conversation with your homeowners. Let them know you spent all this extra time and effort making their homes tight and energy efficient, and let them know this is their mechanical ventilation system. And in my opinion, 5 minutes an hour is probably right for a 3,000 square foot, 3 ACH home without pets and a bunch of contaminants indoors.
So I'll tell you something that I did. So I was hired as a consultant by a college in Tennessee to work with them residential construction program. And one of the projects that they were working on, and I was working with the dean of the mechanical department, one of the projects they were working on was taking a Habitat for Humanity builder from non-code compliance to Energy Star in one house during a blitz build. So if any is, there's a crew that shows up at 7 o'clock in the morning, and they work until it gets too dark to build, and they build the house as fast as they can. Usually the house from foundation, the foundation is already there, but from foundation to turning the keys over is less than a week. So it's a pretty crazy system. And so they wanted me to help these guys go from non-code compliant to Energy Star in one house on this blitz build. So one of the things that I did was I talked to the homeowner, and I risked my $1 million errors and emissions insurance policy. I came back to the mechanical engineer that was running he was the dean of the department that I was working with. And I said, listen, I've done the math, and the mother smokes, but she smokes outside. They have a cat, but it craps outside. So they're opening and closing their door a lot. And they got 2 teenage kids. And on average, they're opening and closing those doors, I think it was like 12 times a day plus. And then we wired the bath exhaust fan so that it was hardwired to the light switch. So you turn on the bathroom light, the bathroom exhaust fan is running. And we had that, it was a Panasonic system that was exhausting about 100 CFM. And then the kitchen range hood, we gave very explicit instructions: always use the kitchen range hood, no matter what you're cooking on the stove or got in the oven, turn the kitchen range hood on. And we didn't provide any whole house mechanical ventilation at all. This was back before the Energy Star program required it. Zero.
Sounds like you had
because
enough.
I figured out, pardon?
Sounds like you had enough to me with what was already happening there.
Yeah, because I figured out that, it was a super tight house, super tight duct system. But I figured out that just by them opening and closing the doors to get in and out of their house and to let the cat out and to go outside and smoke and whatever, just under normal operating conditions, there's a lot of air being exchanged that they didn't need it. And then the homeowner moved in, and about 3 months later, the newspaper did a follow-up story on her. And the dean of the department, when I was visiting him, he showed me the newspaper article. And in the newspaper article, she said that she couldn't believe, the number one thing that she liked about her house was all this clean, fresh air that she has. She couldn't believe how much better the indoor air quality was in her house. And she said that she could leave a bag of potato chips open on the counter and they wouldn't go stale for 2 weeks. And everybody was chuckling about this, like that's her metric for, determining the quality of her air.
That's a good
But
metric.
it turns out that's not a bad metric, because the reason they go stale is because of moisture. And by controlling most of the sources of the moisture in the bathroom and in the kitchen, we were really keeping the moisture, the relative humidity down where it should be. And she was just ecstatic. She was over the moon with all the clean, fresh air that she had.
That's awesome.
And I tell this story, and it's absolutely true. I've got a copy of the article. But the thing that gets me is people still, building science guys will still argue with me that we've got to have it. And I go, well, what's the capacity of the human lung? Is it 7.5 cubic feet per minute? No way in hell. We'd have lungs the size of a water buffalo. This is ridiculous. So I tend to think that we overventilate to begin with, just based on that. It's an anatomical problem. And there's no reason for that. You don't need 7.5 cubic feet per minute per person. There's no medical science behind that. So that's my sticking point with it. So I'm happy if we have it. The problem is that that's not what the code says. The code says you have to bring in X amount, and it doesn't care where your house is. It doesn't care how you do it. It just says this is the amount that you have to bring in. And once, you start digging into it, you kind of figure out like, oh, well, this doesn't make a lot of sense. We could actually be causing more harm like we have right here. This is what we saw up in Maryland when they got hit with 2 seriously wet summers in a row. Dramatic humidity increases in the home. Again, most of the HVAC systems to this day are still grossly oversized. In spite of the fact that, code departments are getting manual J load calculations, but a lot of them aren't actually looking at, they're not using the ACCA review document that they made for code officials to check, did they follow the right process to arrive at their answer? They're just saying, yep, I got a manual J, and they file it away, tick that box off. And we're still getting a lot of grossly oversized HVAC systems. So that leads to these really short run times. So they run long enough to satisfy the temperature requirements of the thermostat, but they don't run long enough to dehumidify. And so we end up with humidity buildup in the home, which leads to all kinds of other nastiness. And this was a serious problem, and it becomes more serious the more energy efficient the homes get, the more oversized the HVAC systems become. And this is, ACCA came out with a new design manual for low load homes, so that once you reach a certain level of energy efficiency on these homes, there's an entirely different set of design requirements that kick in to compensate for this, because it's less about satisfying and removing the heat from the house and the air conditioning side. It's more about removing the moisture from the house. So that's a challenge. And this was causing production builders in Maryland, it was an absolute nightmare on townhouses and apartment buildings and single family homes, because it's really hard to fix moisture problems after the fact when it's baked into the system and it's literally built into the house to cause these things. We did come up with a workable solution, though, down here in Texas, although some of the folks at ResNet disagree with me vehemently over this. So that's to use an inline booster fan. So we found some inline booster fans that are available at just about every mechanical supply house. They're pulling about 40 watts, and you can size it for a 15-minute runtime to satisfy the 220 CFM in our example. So that's literally, it's a 6-inch duct with this one booster fan will pull 220 CFM in, and you put it with a motorized damper and timer control. The timer control, instead of being connected to the air handler fan, is connected to this inline booster fan. And this is where ResNet says that doesn't work, in spite of the fact that you can get the manufacturer's diagrams showing you how to do it. Air cycler, the manufacturer air cycler, not as a generic term, but the actual manufacturer air cycler shows you how to connect their air cycler controller to inline booster fans. And 40 watts for 15 minutes is a lot less than almost 1300 watts for 24 hours. Amen. And then, for the humid climates, the big thing is you got to add a dehumidification system. We're seeing this over and over and over again. We're seeing moisture problems as we tighten up the building envelope, and we're doing a lot more air sealing. We're seeing more spray foam being installed. Even if they're not using spray foam, we're still seeing a lot more air sealing because they've got to meet the mandatory or be lower than the mandatory ACH, air changes per hour requirements for infiltration, and that gets tested now. Tighter houses, more humidity inside the house if the HVAC system isn't designed right, and it rarely is designed right. It's such a serious problem that we're just about everybody's scrambling around trying to figure out how do we get these things to work, because what's always been done in the past doesn't work anymore when we've changed the rules, and we've changed the rules a lot. And it's like, okay, let's get everything to work together as a system again. We've got to get back to that. And so we usually find that one of the big answers is put in a dehumidification system in the hot, humid climates. Because it always, at the end of the day, it goes back to this. The purpose of this is moisture control in the kitchen and the bath. Odor control, maybe. I had one homeowner, I put in one of those continuous run Panasonic fans. So these things are like dead quiet. And she complained, she called me and she said that her bath fan wasn't working. So I had to go out there and throw a piece of toilet paper up in the air so the fan caught it and sucked it up to the face of the grill of the fan, and proved to her that it did work. And then she asked if she could have the noisy fan because she didn't want people to know what she was doing in there. And I said, they saw you go into the bathroom. Everybody does the same things in their bathroom. They know. Don't worry about it. But we always find that that's usually one of the big challenges is homeowners don't like the silent fans. They like that sort of background noise. And I always tell them, if you get a white noise machine or something and stick it in your bathroom. And then the big reason we have the whole house mechanical ventilation is to dilute pollutants. That is the number one reason that we have it, is to dilute the pollutants that are inside the house. And that's the moisture typically caused by the people, which is why we have a CFM per person requirement. And then there's the pollutants that we find in the building materials, the paint and the carpet and glues that are used throughout the construction process. Those are the reasons why we have to have it. But how much do we have to have? Personally, I don't think we need as much as the code requires, but my opinion doesn't count when it comes to the code. The code is the code. That's for the building officials to determine, not me. And they can do that at their, they've got the authority to get that through their systems, not mine. So we're done. At least,
and that's a great message to the building officials on the webinar, because I couldn't agree with you more. I mean, I think those ventilation rates are designed for the little old couple that never open a door and that have 3 dogs and 2 cats and cook 3 meals a day in the kitchen. And then I think those ventilation rates are about right for those folks. But for a younger couple that kids run in and out, or heaven forbid, you're old school like me and like to open a window, I just think they're grossly overventilated. And when they updated 62.2 and dang near doubled it, it just made it worse. And I think, as a code official, you want, I don't think going to your building standards board and adjusting those rates is necessarily your right move. In my mind, the right move would be to have a code compliant ventilation system capable of meeting those rates installed, but having it controlled or otherwise such that it doesn't bring in that amount of air. I love your your habitat story, you know, where, and ultimately it's and why it's broke in the code. And yesterday at Corpus, and I noticed the building official in Corpus chimed in. He said, just turn the faucet on when you're in the bathroom. I've never heard anybody complain about their exhaust fan being too quiet. That cracks me up. But you know, when you go back, it's broken in the code because this is based on human behavior. And I love the fact that you ask questions of the homeowner. You know, had that woman smoked inside rather than out, it's a totally different thing. And so my big message to the builders and ultimately the code officials on the webinar today, it's y'all's job to get this information to the builders, because down in Corpus where I was yesterday, I see somebody from Beaumont on the call. These really humid climates, if you are bringing in 24 hours a day, what is required in code in those humid climates in a really tight house, especially a smaller house, you're going to have problems. It's just absolutely going to create problems. So I think coming up with, it's a conversation, number one. You have to implore your home builders to have a conversation with the home. How many times is that Honeywell controller and the little dial installed on the air handler set for 5 minutes, and which is probably fine for my wife and I and our kids, but the little old couple with 3 cats and 3 dogs, they need to be aware to go up there and turn that thing up a little bit. And then frankly, having your air cycler, having your air cycler being your fan to bring in outdoor air is preposterously dumb. It goes against the intent of the energy code. And I think for the code officials on the call today, you are well within your right as the authority having jurisdiction to make the call. The intent of the energy code is to save energy. If your mechanical contractors insist on using the air handler for mechanical ventilation, to me, that's a pretty easy no. You can't do that anymore because you're not meeting the intent of the code. That standalone booster fan, I'm a fan of AccuFresh. Just my buddy started the company, Tom, and I've seen his product tested against. Panasonic makes one, Braun makes one. A lot of them make good ones. But my point is, for just a few dollars more, I mean, that Honeywell controller is like 80 bucks, probably $100 by now. Well, you can get a smart standalone fan. The smaller Q fan pulls 32 watts. It's got a MERV 5 filter on it.
Yep.
And when it's 90% humidity outside, it runs for 5 minutes, says, oh my gosh, it's 90% relative humidity, and it shuts off and doesn't turn back on for an hour. Comes back on in an hour, it's still 90% relative humidity. It'll run for 5 minutes, shut off. And just the point being, for literally under $200 more, you can go from a dumb ventilation strategy that uses the air handler motor to a smart sensing temperature and humidity ventilation strategy that uses a pre-filtered 32-watt motor. I mean, that's just an absolute no-brainer. And I think the building officials are well within their right of making that call to meet the intent of the energy code. I just really think they are. Did have a few questions come in. Arnold says, why are electricians installing exhaust fans when they are listed in the mechanical schedule on mechanical plans?
I have no idea, because when I was building houses, I made sure that the electricians didn't touch the damn things. It was my HVAC contractor's job. But it's just something that it just started happening. And I guess the electricians go because they're running the wires and this thing's hardwired. That's their job. But I looked at it as this is part of the mechanical system of the house. It belongs to the mechanical contractor.
Right.
But it's just something to see.
Yeah. And, you know, when vent hoods, now everybody, especially, I mean, if on any sort of any home over 3,000 square feet, you know, everybody thinks they're a chef these days. And so we all have that kitchen vent hood that pulls more than 400 CFM. And of course, code, once you get over 400 CFM on your kitchen vent hood, you've got to have an opening to the outdoor adjacent to that room to bring in outdoor air. And so Juan Felipe's got a couple of questions. I think that's really only where you're going to get that. I'm sure there's some builders doing it. But anyway, he asked, isn't there a positive pressure opening on some new construction? A vent opening that opens and closes dependent upon indoor pressure. And would that assist in bringing in additional ventilation? Got any thoughts on that?
Yeah, they do make those systems. They're generally a bad idea because you don't get to condition the air at all. It doesn't get evenly distributed throughout the house. So if there is a lot of moisture in that air, you have less opportunity for it to be dispersed and have the potential for some of the building materials to absorb some of it. So you're not getting a big hit in one spot. And then there's no filter typically on those things.
Yep. So
you're just getting unfiltered air coming in. So whatever pollutants are outside are now inside. It boils down to the thing that it doesn't really meet the requirements of the code for whole house mechanical ventilation. And as much as I disagree with the amount that's supposed to be brought in by the code, we still want to have it in a controlled fashion, and just having it randomly depend on whether we're turning on our clothes dryer or we're cooking at our 2000 CFM range hood. I'll tell you that story. We don't want to rely on those passive systems to do this. We really want to be able to control, when it's too hot, when it's too cold, when it's too wet. We want to be able to control all of those things. That's why those systems just, we used to call them the poor man's HRV. We would dump that, we'd bring a passive system like that and dump it behind the refrigerator coils in the kitchen. So it was always, in a cold climate, it's always getting warmed up. And also because it's warmer back there, it reduces the relative humidity of the air if you measure it, but it doesn't remove any of the moisture. It's manipulating the relative humidity. But we called it poor man's HRV.
That's kind of
I never did that, but I saw people that were doing it. I was like, that seems like a bad idea.
Yeah, but just using the air handler in general. And I'd be curious to get your thoughts about this. Was having lunch with Garrett Dorsey yesterday in between my classroom and my field training in Corpus, and during my drive from San Antonio to Corpus, I couldn't help but notice the petrochemical plants just spewing. I mean, just, oh my God, just shooting out. I'm sure according to the company that operates that, it's just steam. That's all it is. But I have a sneaking suspicion that it's probably not. And what would be your thoughts? And I never even really thought of this. I mean, I saw some products at the ACA convention a couple of years ago in San Antonio. But I think as our environment gets worse and worse, and our homes are, getting tighter and tighter, what about UV, charcoal, other air scrubbers? And sometimes in the year, we're just saying, screw it. We don't want any of that outdoor air in here. That outdoor air is awful. Let's scrub UV, charcoal. Let's treat our indoor air. Have you put any thought to that at all?
Yeah, one of the big challenges that we have, particularly like when coronavirus hit, there was all of a sudden this big rush for improving the indoor air quality of the houses that we're now stuck in. And so there were a lot of people were selling these UV lights and installing UV lights into the duct systems of the HVAC systems, trying to kill whatever bugs they could. And the reality is that UV lights in the duct system don't really work that well, not even for inhibiting mold growth, because the particles aren't exposed to the UV long enough, because the air is moving pretty quickly through there, not exposed for a long enough period of time to kill anything. Mm-hmm. And so, to like inhibit mold growth on a coil, you actually have to point that UV light at the coil.
That's what I saw. That's what this product was. It was inside the air handler in the coil, shining on the coil.
Yeah. So it'll kill whatever's resting on the coil. So it'll inhibit mold growth, but it's not going to kill any particles that are zipping through the air.
In the air,
just because they're moving too quickly, Yeah. there's that, but then, you have some things like the charcoal systems. So we always we try to follow this, kind of an approach where, the first thing we want to do is we want to build the house tight to keep pollutants out. Then we want to remove whatever pollutants that we can find in the house. Let's just get rid of as many pollutant things as we can. So, kick the smoking cousin out, have your dog sleep outside. I don't know. That's my number one choice is always put pets outside, but I was raised on a farm where we didn't have pets.
Hey, I've got a 14-year-old. If you have teenagers, you need to make them sleep outside too, because this child smells.
I had 4 boys. They've all left the house now. So yes, sometimes opening their bedroom doors required a hazmat suit.
Oh my God. Son, you don't smell yourself? Really? You don't smell your, no?
Yeah, pigs don't know pigs stink. That's the answer to that one. And then, so we do that, and then we want to filter things. So filtering is kind of like one of the last steps. And so I'm a big proponent of high MERV filter systems if the HVAC system is designed to handle those. Too often we find they're not. And one time I was working with some folks up in the Dallas area, and I'm poking around in the attic, and they've got a 4-inch pleated media filter box, and I opened it up, and the homeowner had put in, instead of buying the expensive 4-inch pleated media filter, they decided to put in 4 1-inch pleated filters, which has an entirely different static pressure. And it's like, no wonder your system's dying up here. It's just that kind of nonsense that happens. Every time I argued with Achilles Kurzagis one time. He had this idea that software could predict the stupidity of humans, and my point was that you never can. Every time you think you've beaten the idiot that could show up, God creates a better idiot. And it's like, you can never gauge this. Who would have thought that you would find a dead raccoon in an attic knee wall inside the insulation? Like, wow. Who would think that would happen? But wow. It did. Who would think that people would carry a toilet into an attic, leave it laying on the ceiling joist, and then an insulator fill it up with insulation and call it good? Like, that's deliberately going out of your way to do something crazy. And people, they do it all the time. Every time I think, we've designed an idiot-proof system, there's somebody will figure out a way to break it. And so we're always having, those kinds of challenges. So, like, how do we design the best idiot-proof system we probably can? And, it boils back down to the simple basics. Build the house as tight as we could without making it too tight. So let's meet the code requirements, but let's not be excessive about it, because we're also finding out that once we reduce the amount of airflow through the building envelope to a certain point, we end up with moisture accumulation inside the building envelope, because that airflow that was moving through there, as little as it was helping to remove moisture. But now, we're getting them so tight that there is no airflow through there to dry these things out. So any kind of moisture that gets into the wall assembly is basically staying in there. So the inside of the wall assemblies aren't being able to dry out as well. So let's just pay attention to these things and try to figure out how do we bake this into the structural system in a smart way, and then how do we deal with whatever's left over with mechanical systems that we can tweak. But in order to do that, you've got to be able to think about ventilation, think about the purpose and the intent of the code, the purpose and intent of ventilation, and apply some human common sense. And this is where, we run into problems.
Yep. And then he was just asking about that timer on the exhaust. Well, that runtime, that's only if you don't want it to run. So basically those default CFM requirements and code, that's based on a 24/7, 365 runtime. So you would really only need the timer if you're wanting to run less than that if you're wanting to increase the CFM but run less time. That's when a timer would come into play. Guadalupe asks, what about UV lighting in the air supply duct using a variable speed air handler that's on a continuous fan only, lowest speed? Would that allow the UV light to work? I think the air is still moving too fast. But he says, I'm talking about the Ream Halo UV. I'm not familiar with that product. Are you familiar with that?
Yeah, all the manufacturers are trying to come up with something more, another gadget they can add to the contractor's toolbox so they can all make more money. And the reality is even if it's set running on the lowest speed, the airflow through your typical well-designed HVAC system is too high. The particles just don't stay there long enough to get that kind of serious damage, and it's a challenge. And that's why, like, the UV lights work when you point them at the coil, because it kills whatever is going to rest on the coil. But anytime you're pointing it into the moving airstream, it's not going to be through there long enough to get zapped. And we see all kinds of slick marketing stuff from folks, but at the end of the day, we kind of go, it's slick marketing stuff. This stuff doesn't work.
Yeah.
We had it's just I can't tell you the number of times we've had crazy schemes come across the desk, and they're they think they've got the greatest gizmo ever that is going to revolutionize the construction industry. And I ask them simple questions like, well, is this better than felt paper? Is it going to outperform felt paper and gravel? Like, what is it? How is this going to work? And what are the problems it's going to cause? And it turns out I have a knack for finding problems, which is my curmudgeonly approach.
Hey, welcome. I welcome to the team. We're fellow curmudgeons. I love that you mentioned felt paper. I built a cantina bar in my backyard, and I used 2 layers of 15-pound felt as my WRB. And I had the Tyvek rep meet us out in the field for our field training yesterday in Corpus, and love Tyvek. I think it's by far superior to all of that type of product, the roll WRB. But the building official, we're out there in the field and we're looking at some pretty bad WRB installations, and somebody brought up the question to her, like, well, what about felt? And she, anyway, she's like, well, we've heard that anecdotally, blah blah blah, you get back behind there years later and it just crumbles. And he's like, well, I had a house built 80 years ago and replaced the siding last summer, and it was in perfect shape still 80 years later. And I was like, well, it'll crumble if you leave it in the sun for 2 months before you install it. The UV will degrade it. But me personally, I used it on my cantina bar. I like felt. It works. And especially, it's not a real tight operation. It's designed to get wet, and it's mainly designed to drink beer at, but it's real good at that. Robert asks, and no, Robert, but I know Corpus is requiring this, and I think it's a good idea because, in my opinion, if you're going to use that 6-inch duct, run into the controller, run into the return plenum, and I hate that way to ventilate a house, but it does meet the supply only the mechanical ventilation requirements, as long as you're using an ECM motor on your HVAC, but it's still pulling way more watts than it should. But everybody will tell you that exhaust only is the absolute worst. I think it's the second worst. I think using your air handler is the worst. And if builders are using exhaust only, they are by code required to at least install one really good exhaust fan. It'll typically say Energy Star 62.2 on the package. It's a 2.8 CFM per watt, I believe, is the code requirement. But long story short, if you're going to use exhaust only, you've got to upgrade one of your cheap little builder exhaust fans to a better one. And to me, and Robert asked, did I imagine having to label the switch on a whole home mechanical ventilation device, normally found in the laundry room where they don't have a fresh air intake? And all code requires, Robert, is that it be controlled. It does not say anything about labeling it. But to me, if the builder's strategy for mechanical ventilation is going to be that one upgraded exhaust fan, I think you absolutely should have that control labeled whole house mechanical ventilation or something to let the homeowner know that this is the fan that needs to be turned on. You have any thoughts on that, Brett?
Yeah, the code doesn't require it to be labeled. It's a really good frickin' idea.
Agreed.
But Energy Star does require that the homeowner have access to the control, and the control has to be clearly labeled. So that's one of the requirements in Energy Star, but it hasn't quite worked its way into the code yet for those controls. But it's a really good idea.
I see. Personally, I think so too. I mean, I think it should absolutely be labeled, just because it's, the homeowner that doesn't go in and out to let their dogs out and cats out and doesn't, and has pets or whatever. I mean, they need to know that's the thing that they need to turn on and leave on. And it's going to be a spectrum. I mean, if you go out some, but a smaller, tighter house, you just turn it on at night before you go to sleep, or you put it on a timer, or there's a bunch of ways to do it. As a code official, you need to know that the system they installed is capable of meeting code. But again, that conversation with the homeowner about, hey, how do you live in this house? And this is what it is. I did have one more question come in, but I deleted it on accident and don't even see it. What about, curious, Brett, now I even lost my train of thought. Well, it must have been I don't know what it was.
So I'll tell you a funny story though about the 2000 CFM kitchen range hood.
Okay.
So this was a builder's custom home that he built himself, all concrete, except for the roof deck, which was wood frame and spray foam. And he's got deep water access. He's down in the coast of Georgia, and he's got deep water access with a big dock and a boat and everything. And the spray foam manufacturer called me in. They were bringing their own building science guy in from North Carolina, and they were bringing the insulation sales rep, and the builder was there, and all these other guys were there, and they asked me to show up. And so I showed up, and their building science guy was running around checking the condensing potential of all these surfaces in the attic. And I was like, well, the reason we came down here is because he was grilling fish that he'd caught outside, and he came inside to cook some vegetables on the stove. And when he turned on his exhaust fan, his kitchen range hood, his house filled up with smoke from his outside grill. That's why we're here. I could care less about condensing potential of any surface in the house. I want to find out why he turned this 2000 CFM kitchen range hood on. Why did the house fill up with smoke when it's concrete, right? We shouldn't have any holes that big.
Right.
So I did something real simple. I went down into he had a walkout basement, went down there and moved some ceiling tiles around because I saw a light switch, and I was flipping the light switches, seeing which one controlled what. And I saw this one light switch went underneath the deck, and you could drive through underneath the deck in the back of the house. And at the end of that deck, it was supported by a shed, and there was a light outside that door. And I flipped this light switch, and the light came on way over there. And I thought, how did the electrician run the wire way over there for this light switch? And so I moved the ceiling tile, and there was a 1 foot diameter hole cut through the bond beam for a single line of Romex, because the guy had to use a jackhammer on it. So,
yeah.
So I was looking at this, and I thought, okay, I'm going to play a trick on this guy. So I moved the ceiling tile back, climbed down off my ladder, moved my ladder over about 3 feet, and then called the builder down and said, hey, I got a question for you. I said, I bet I figured out what's going on here. I said, I bet all the smoke came in through here. And he said, no, that's just it's like a 1-inch hole. And I said, I bet you $100 that hole's bigger than an inch. And he said, you're on. And he climbed in. And so I said, why don't you look at, I don't know, that ceiling tile. And I pointed over at this one. And so he moved it over there and he pops it open. He goes, son of a, and then a whole bunch of other profanity. He never paid me.
No.
But I started going through this with him and I was like, okay, so there's some things going on at work. Yeah, there's a hole here that shouldn't be here. But the bigger question is, why do you not have makeup air on this 2000 CFM kitchen range hood? When you turn this thing on, did your dog get magically drug into the kitchen? I mean, this is like insane.
Yeah.
And he said that he paid a mechanical engineer $100,000 to design the mechanical system in this house. And the guy neglected to put in makeup air for that range hood. And I said, dude, you need to get that money back because this guy failed horribly at his job. Meanwhile, the spray foam building science guy was still up in the attic trying to figure out whether moisture would condense on the can lights, the tops of the can lights exposed up there. And then I turned on a blower door to prove that, yes, you can move that much air through that hole. But it was like, are you nuts? You put in a 2000 CFM range hood and no makeup air? Like, what did you think was going to happen? And yet we see it all the time. People put it in 600 CFM or 1000 CFM because, they think they're emerald. And, next thing we know, bad juju, and they don't know what happened and they can't understand why.
It's got to be connected to a motorized damper. You turn that on, the damper opens. That's crazy. What do you think?
Like in code.
Where I see it going in maybe 3 to 4 code cycles at the most. What I would imagine is the good old PM 250, CO2, just the handful of most common indoor pollutants. Basically, what I see in the code being required within 3 to 4 code cycles is indoor air quality monitors tied to your mechanical ventilation system. What do you think about? Do you think that's coming or no?
I certainly hope so, because ultimately that's what we really need, is just let's personalize and customize the ventilation system to reduce the pollutants in the house based on the friggin' pollutants that are in that house.
Amen.
Amen. Instead of trying a one-size-fits-all approach, no matter where you are in the country, which we know doesn't work. The reason we know it doesn't work is because we've got lots of houses that are failing because it doesn't work. And the only way we can get around that is when we start customizing those solutions and get that into the code so that these things can be customized for each individual house based on the pollutants that that house has, and get some good controls so that we don't end up overventilating on hot, humid days, or like God help us if we have another snowpocalypse, cold days, where then the HVAC systems have to work double hard. And let's reduce the amount of energy that's being used to ventilate the homes, because the purpose of the energy code is to save energy. And that's one of the things that just baffles me. Like, and I know the way the HERS index gets calculated way better than almost everybody else in the country. Philip Ferry and I, Philip told me that there's probably only 4 people in the country that know how that thing actually works, and I'm one of them. And it's like the HERS index actually gives you a lower HERS index when you ventilate to the ASHRAE 62.2 requirements. Even though you're using more energy, you end up with a lower HERS index, because people don't realize the HERS index is not based on energy consumption. It's completely disconnected from energy consumption. There's no correlation, zero correlation between the HERS index and energy consumption. So you can get a low HERS index even though the house is using more energy, and particularly on the ventilation side. And we also found that there's about 25 energy raters throughout the country that in the past were fudging the numbers on the fan wattage when they were entering data into the software tools so that they could get good HERS index numbers when they were using the air handler fan.
Yeah. Oh yeah.
And
we saw that. We saw that.
We know who they are. ResNet hired me to find them. I found them and turned it over to ResNet, and ResNet didn't do anything about it. But this is the kind of nonsense that happens. But now, as a consequence of that, we did some massive quality controls checks in the ResNet system to prevent that from happening again. So now if they put in an unreasonable answer, then it gets flagged. So it's like, hey, dude, this is not the right answer. This is completely unreasonable. But again, for a long period of time, there was 25 out of 5,000 is not that's a very small number that were actually doing it, but they were working on a lot of houses.
Yeah.
So they had a pretty big impact. But ResNet did put in, we did manage to get the quality control checks in the system to flag those guys. But again, it just like when people rely on the HERS index, which is not the same as the energy rating index, they rely on the HERS index for energy code requirements. You're not actually necessarily saving energy just because you got a lower HERS index number, because they're completely disconnected.
Yeah.
And that's the sad truth.
Yeah.
And unfortunately, we still find that a lot of jurisdictions are baking the HERS index, which is a proprietary rating system, into their local jurisdictions codes. And it's kind of frustrating because they don't understand how that works. And there was a little bit of a punch up on LinkedIn after the last webinar that I did for y'all, because there was some folks in the rating industry were arguing that I was not right. And I'm thinking, you have no idea how the HERS index works, because it's not based on energy consumption at all. So it's based on energy loads, which are not the same. And anyway, it's kind of funny. I stay out of those social media fights. There's plenty of other people that'll take up that mantle and jump in.
Yeah, I stay away as well. I didn't know. I'm glad that we're causing fights from our webinars, though. That makes me happy.
Well, it's one of those things. If you're a curmudgeon, there's going to be a fight somewhere.
Yeah.
And there's a lot of folks that, God bless them. They're trying their best. They just don't know what they don't know. And they run around like they're experts on things, and they've never been in the dirt. They've never been part of the grind. They don't know.
Yeah.
They don't know how the HERS index works. They don't know how the HERS index gets calculated. They don't understand these things.
Yeah.
And they don't understand a lot of the building physics. We taught an advanced psychrometrics course to an engineering firm a few years ago, because they wanted, said, we're all a bunch of professional engineers. We just want some additional training. We're all pretty good about this stuff. We'll figure it out. And they had no idea that vapor pressure on the Gulf Coast, how huge it is and what an impact it has. They were all attributing the case studies, because I wrote a case study about this house, and the reason it failed was because of the tremendous vapor pressure being on the Gulf Coast. When your backyard opens out onto the Gulf, there's a lot of humidity in that air, and there's not a lot on the inside. And the humidity in the air just it's this intense vapor drive through the building assembly and into the house. And it was causing the house to fail because they didn't have the right building assembly for that. And they screwed up a bunch of other stuff. And this entire engineering firm, there's 20 some of them went through the class, and they all came up with the wrong answer. And they were all saying it was the stack effect, which is the effect of hot air rising and cold air falling. Well, that had nothing to do with the amount of moisture in the house, which was causing the mold to bloom everywhere. And that was their answer to every single person. And we're like, okay, let's explain this again. Here's what's going on. And so when we had that discussion, the senior manager of the company came to me afterwards, and he said, that was a little too intense for our people. do you have something that doesn't require as much knowledge? I was like, you guys are engineers, for heaven's sakes. You should learn this stuff when you're getting your engineering degree. But we used to say building science isn't rocket science, but sometimes it sure seems like it is.
No, I've given a presentation for a couple of different ASHRAE chapters, and I've been a little taken aback at a question or two. Okay, well, anyway, I'm not. Anyway, it is what it is. Oh, Brett, once again, I can't thank you enough. I mean, that was fantastic. It really was. And you're in Seguin, right? Oh,
Yes,
I
sir.
don't even rat now where you are. I need to get you out in the field doing some of this field training with me sometime. I don't know what it'd take to coax you out into the field, but and that's where you're really, I mean, you see it all the time. I mean, you've been in the field a million times, and that's when you really see, and I was writing a proposal for DOE the other day, and, you know, they want some sort of blanket statement. What are you going to do? And just let them know that, hey, I'm going to do what is required in that jurisdiction. I'm going to go look at the construction practices, how they're doing things. And it might be A, B, and C that needs to be worked on in one jurisdiction, but it might be C, D, and E in another one. And you're not going to know until you get out there and put your eyes on the construction practices in the city. And it's remarkable, as I do more and more of these field trainings, how similar the construction practices are from jurisdiction to jurisdiction. I mean, like all the builders in El Paso put foundation insulation and don't pay much attention to the weather resistant barrier. And when I was pointing out some of those deficiencies, the solution was, well, it doesn't rain here much, so it really doesn't matter. Well,
yeah, that's what they told me. Yeah, you know, I'd love to get out in the field, and it doesn't take much to get me out there and doing things. You know.
Cool, awesome. Well, thanks so much for joining us, everyone. And Brad, thanks again for doing it for us. We'll get this up on our YouTube channel in a day or two. If y'all need to rewatch any of it, it should be up there. I guess that's all we have.
I'll have the slide deck.
Oh, yeah. If you'll email me that slide deck, I'll get a copy of the slide deck. Oh, and for your ICCCUs, as always, just fill out the course evaluation. It's actually Kathy sending those out now. So we'll send you a copy of the slides, fill out the course evaluation. We'll get you your CEUs. Thanks. Oh, we got one more chat came in. Oh, just a thank you. Thanks, Patricia. Glad you were on. Thanks for joining us, everyone. Have a great afternoon. Y'all go ahead and take the rest of the day off. Let your boss know I said it was okay. Thanks, Brett. Bye, everybody.